Okay. So once we will go with the remaining two topics, annotations and metadata also. Okay. So next topic is our annotations topic. Okay. So this annotations topic is like we can call it as whenever we want to store the metadata of our object or of our method. Okay, then we'll be use the annotations. Okay. So that is actually in the previous versions of a Java will be use annotations especially for the metadata. Say for example, if I'm creating a class as XYZ. So whenever I'm providing my code to the any other new member, I want to provide that who have created my program and who have created this class and when they have created. Okay, then we will be write a annotation like this at the rate symbol. Say for example, if I want to give the author name, I can give it as a author space. Say for example, Pravina. So I am specifying that author is the Pravina for this class. And at the same time, if I want to create a date and time of this, I can specify the date as say for example 4 11/25. So this becomes a metadata for my class. That is this class is created by this particular author, this particular date. Okay. These similar annotations now within the current versions we are using for predefined code or predefined our default code. For default codes and predefined codes also we are using annotations in our current versions of the Java. That is say for example, if I want to specify the one of the method as a overrided method. Say if I'm creating a void run. Okay, this is a method of my base class thread. And I want to mention that this method is a overrided method. I can create a I can specify the annotation as override before this particular method. Then the compiler understands that this method is a overridden method. That is, this method is already defined in the base class and which is overridden by this particular our current class. Okay. So this annotation gives the compiler the complete information which is required for this particular method. Okay. So like this, we have some existing predefined annotations, okay, which are at present we are using in the new versions of the Java. Okay, these are the user-defined annotations. Okay, and these all are the predefined annotations. Okay, so which provides us some information to the our compiler, so that compiler understands the what is actually the purpose of a method and how it is to be used. Okay. So in our new frameworks like Struts framework and others, okay, we'll use a lot of annotations for especially for to perform the some most of the predefined work can be done by the our annotations. Okay, say if you want to create the constructors and destructors and get methods, set methods, those all you can mention with the help of annotations. Without writing a code, you can write the annotation and constructor will, that is our compiler will assume the meaning of an annotation and it will do the its own work. Okay. So you can simply define that annotation is a keyword used to define the metadata of the class. Okay. And these keywords can be used by can be a user defined or can be a predefined. Okay. So example is date, author, these type of annotations. Predefined is override is a one of the predefined annotation. Okay. So this gives us the some additional information to the our class. Okay. At the same time, it gives us some additional information to the other members with from for whom we are sharing the our code. Okay. So note down that definition, whatever I have given, that definition and the two types of annotations. One is a user defined, another one is a predefined.
Ma'am,
Yeah.
some people are waiting to join.
Okay. 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 So this is also the example, small example of annotation. Like here, the annotation is @ interface is the annotation. That is, you are mentioning that your this whatever the user defined data type you are creating, that is a interface. So generally, actually, we'll use a interface as the keyword. Okay. This annotation can also be used for that specifying of the class as this particular object as the annotation, the interface. Okay. So wherever you are using a @ okay, that can be called as a annotation. Okay. So compiler finds the defined meaning for that annotation, and based on that, it can find the what actually the meaning of annotation and how it is defined. What is the value of annotation? Those all will be finded by the compiler. Okay. Okay. Some of our annotations are the built-in annotations are like this. So one we already discussed, the override annotation is one of the built-in. Retention annotation, documented annotation. This is generally used for documentation purpose or comment specifications. Target, where you are actually your program is to be compiled or program is to be loaded. Okay. And you can also specify the one annotation as an inherited annotation. That is, you can mention that your class is the inherited class of another class. Okay. And your method as a deprecated method. If the method is not available in the current version, you can mention it as a deprecated method. Safe variable arguments. Okay. Suppress warnings. Sometimes whatever the warnings you are getting from your program, okay, those warnings you can suppress with the help of a suppress warnings annotation. Okay. So these all annotations are provided with the package is the java.lang.annotation package, language.annotation package. Okay. So there are the lot of annotations which are provided by the Java as a predefined annotations. Okay. And this is a example for the annotation. So here we are creating a one built-in class as the animal class with some method as a eat something and which prints the message as eating something. And then we are creating a one of the class as a dog class as the child class of the animal. Then I'm specifying that override as a annotation, and the method which is provided in the base class, the similar method we are providing in the child class as I eat something with a different message. Okay. So that whenever you specified the override annotation, the compiler assumes that this is the overrided method. So it should follow the same signature of the base class. Okay. So otherwise, actually, without annotation also we can write. But if I'm writing a difference in the arguments, like say, for example, eat something of int A. So then our method becomes as a different method. Okay. So that it cannot be considered as a overrided. But whenever you are specifying an annotation as a overrided, then you cannot change the any part of your method description. Okay. Because our compiler matches with this method with your base class method. So this method must be as same as your base class method. Okay. You cannot modify even a single letter or access, or you cannot modify the return type, or you cannot modify the parameters. Okay. And just we are creating an object for the dog class and storing in the animal object. And a dot eat something, it just calls the method in the dog class because we are instantiating the a object with the dog class. Okay. So that whenever
ఎట్లో పాపే వండుకొని నిన్న
a
సాసం
dot,
పంపించచ్చు కదా మరి
okay, somebody are
ఏమంటుంది
unmuted, just mute more. Okay. So you can call the method which calls our child
అంటే
class method. Okay.
అని చెప్పి అందుకే వేసిన.
So here see the error. We are provided the override keyword, but what is the change in this?
అందుకే జల్ది రమ్మన్నాం
Can you observe what is the
తీసుకొని
change in this?
ఇలా తీసుకొని రమ్మని పెట్టనైనా పెడతా లేకపోతే పంపినైనా పంపిస్తా. ఇద్దరు పెట్టుకోవచ్చు అది. పెళ్ళికి కూడా అవుతుంది మంచిగా గోరింటకు. మరి గోరింటకి ఏం చేస్తారు?
Okay. So here the change is in the base class method, S is the capital letter. S is the capital letter. In the child class method, S is the small letter. So whenever you are trying to whenever you are trying to compile this program, okay, then it checks the override annotation is there, so that you cannot modify the definition of the method. So it gives a error message here. Okay. So this is related to the annotations. Okay. Next we will see with the generics. The IO classes we have in another one. Next we'll go for the topic is generics. Okay. So generics is generally we will call it as template. Okay. Say for example, say if I have the different data types and my method code is the same for the multiple types of data types. Say for example, I want to do the sum of the two numbers. Okay. So int A, int B. Okay. And my code of the function is int C, C equals to A plus B, return C. Okay. And if I'm giving a return value as the int. Okay. So within this, if I change my int data type as the float, so then only the change is here in the first int and these two parameters are converted to the float and your result variable converted to the float and your return type converts to the float. But remaining all the part of a code is the same. That is, implementation is the same, but only the difference is your data types of the parameters and data type of the return function and result variable. But remaining all the part of a code is the same. So the same code for, say, for example, if the two variables are the float, if the two variables are the double, if the two variables are the characters, if the two variables are the byte type or short type. Okay. Say for user, if I want to provide these all variations. So I want to provide the two float variables sum method, two double variable sum method, two characters and two bytes and two shorts. Then actually what our requirement is, we need to write these many number of methods. Okay. So one method with the int and one method with the float and one method with the double and one method with the character variables, one method with the byte variables and one method with the short variables. Then it becomes a total 6 methods. Okay. So without declaring these many number of methods, so the alternate is the generics. So generics is to provide the template. That is, without specifying a data type for the method, we'll just mention the template. So then this same method can be written as like this. Okay. I need not to specify the data types wherever it is required. I can just mention the template of my function. Okay. So just for understanding, KLB specify your data types as some letter as the T. Okay. T as the data type for all the places. So whenever you are calling this function, say if I call my function with the two integer values, sorry, A comma B. Okay. Otherwise, sum of 10 comma 20. Then the T becomes as the int. If I call my method with the sum of 10.4 comma 15.5, then my t variable becomes double. Okay. If I call my sum method with the 10.5f, 15.4f, then my t variable becomes float. Okay. So like this, whatever the values you are passing with the function, so based on that, the data type t will be replaced with that type of a data type, and the function will be created in the memory. Okay. There are the two advantages by using this generics. One advantage is you need not to write the number of functions. You can write only one function and you can use it for any type of a data type. That is a one advantage. That is so your number of lines of a code will be reduced. And second advantage, that is first advantage is number of lines will be reduced. Second advantage is, so if you are writing a 6 functions, and if you are not using all the 6 functions in your main program, that is, you have created all the 6 functions, but you are using 1 or 2 functions, then remaining 4 functions related storage space will be wasted. Okay, that you can reduce with the help of this generics. Just by creating a one method, it can reduce the number of lines. At the same time, whenever you create as a template or whenever you create as a generic function, it doesn't be allocated the memory space until unless you are invoking the method. Until unless you are not calling a method with a particular data types, it doesn't create the method. It doesn't create the method and it doesn't allocate the any memory space for the method. Okay, so that it saves the memory space also. Okay, so whenever you call your method with the 2 integers, then it creates a function with the 2 integer data types. Whenever you call a method with the 2 floats, then it creates a method with the float variables. Until unless it doesn't be created the method in the memory, so that it reduces the memory space and it reduces the number of lines in the code. Okay. So this is applicable for methods and also for the classes. Okay. Say if the similar class code is to be required for the different types of data types. So example is like stack. Okay, I want to create a stack. So if I want to create a stack with the for int values, that is int stack, I need to create a one class with the int data type. If I want to create a stack with the float values, then I need to create another class with the float type. Okay. If I need for the double, I need to create a one more class. Okay. So creating these many number of classes is the wastage of memory space and wastage of the your number of lines. And also at the same time, the programmer is also has to type that many number of lines of a code. Okay. So which will be reduced by our generics. Okay. Generics are very advantageous, and at present in the Java, all maximum classes are the generic classes, especially collections framework classes. Especially all collections framework classes are the generic classes. Okay, because collections framework is especially for our frequent used classes, which are not restricted for one particular data type, which are not especially used by the one particular data type. We can use the collection framework classes for any type of a data type, okay, just by changing the your required data type while creating the object. Okay. So generally these collections are like a linked list, double linked list, vector, hash table, okay, stack, queue, uh, map. Okay, these all are the general classes which are not restricted for one particular data type. Okay, those all can be used with the generic classes. Okay, those all are created as the generic classes. Okay, so here the definition for the generic classes is the class which is created without any specific data type and the class which is created with a template or with the model of the code is called as a generic class. The generic class can be used for different types of data. Okay. The advantages are it reduces the number of lines and it reduces the memory space. Reduces the number of lines and it reduces the memory space. Okay. So these generics, a simple example is given like this. So these generics are created with the help of one special notation is called as angle brackets. Within the angle brackets, we need to specify a letter. Okay, this is not syntax you need to specify only the T as the letter. So you can give any letter, that is A, B, C, D, any letter, any word or any letter can be given. The same letter you need to use wherever you are wherever you are required the data type, you can specify that letter. Okay. So here T with the data type OB variable is created, with the T data type O is created. Okay. So wherever you require that data type, you can use that. Okay. So simply say for example, if I'm creating a class as a number, okay, I can specify data type as the T. So I can create my variable as the N as the T. Say I have increment increase T as the X as the value, N equals to N plus X. Okay. And for decrement of a value, I can create a T Y. I can reduce my value N minus Y. Okay. So this is my class. So wherever I require, say if I want to return the value, I can use the return type is also as the T. So then I can return my N value. If you are required, you can return. Otherwise, not mandatory. So just I'm creating a simple class like this. Return N. So the decremented value or incremented value will be returned. Okay. So like this you can call. So and you can create the object of this as this is all the example. So you can create like this. So this is your class name, data type for the T, that is whatever you are specifying a T, that for the data type, and your required object. Okay. So this is the instantiation of that object, IOB. Okay. New, the class name, again the data type, and your required value for the constructor. If any value is to be given to the constructor, you can give the value to the constructor. So here in our class also we didn't created the constructor. So we can create a constructor also here. So num is our constructor. You can give the value some n1. Okay, within the brackets you can write n equals to n1 semicolon. So this is a constructor. Num t n1 is your value, n equals to n1. So now you can create for your object as, so num is your class name, integer is your data type. Okay, say some n is your object. Then equals to new num is your class name, integer is your data type. Okay, and for constructor your value, say some 10. Okay, okay, this is the object created now. So from this object you want to use your methods, you can use it as nn dot increment of 20. So your 10 value, existing value is 10 plus 20. That becomes a 30. Say if you want to store that in any particular variable, you can store, say some int x equals to your nn dot increment. Similarly, if you want to decrement the value, you can use it as decrement by 10. And here also I want to store some value in my variable as the y. So you can display the value system.out.println of x. Similarly, you can print with the value system.out.println of y. It prints your value. The same object, the same class, you can use for the other data type as, say for example, num. Your required value is of a float. Okay, num float. N2 new num float. Okay, of 20.5 f. Okay. So similarly, you can do the decrements, increments, and all other. So same class, without changing anything, you can just use for the float data types. You can use for the double, you can use for the characters, you can use for the string, you can use for any other data types. Okay. So this is the advantage of generics. Okay, you can create one class and you can use for the number of other data types. The same class can be used with the different types of data types. Here the string will be passed. Okay. The same output you will get, like with the integer object, this is the value and this is the value of a string object. Okay. So say for example, if your class is working with the two data types, then you can specify the two data types also. Okay, with the comma separation, you can specify the two data types like T and V. Okay, T is the one data type and V is the another data type. Okay, so with the T data type, you can create a one variable, and with the V data type, you can create another variable. Okay. Say for example, if my class is working with the intent float or intent character or float and double or byte and short. Okay, if my class work is required with the two different data types, okay, then I can create with the two types as the my generic data types. Okay. Okay. This is the simple example of two different classes. One is a string and one is an integer. This is related to the generic classes. Okay. I think all of you are understood with the generic.